Hi, dear students. Good morning to all. Yesterday we have discussed um, the topic capacitor, and there I told some introduction part about the capacitor and the use of capacitor, how it consisting of, and how to find the capacitance of a parallel plate capacitor. These all things I have explained yesterday. So today we are going to see. Yesterday I told you capacitor is used to store charge as well as to store energy. So capacitor not only store charge, it stores energy also. For example, I said yesterday the ceiling fan example. Sometimes it won't work when we switch it on, but when we take a stick and the blades, if we rotate, what will happen? The fan start to rotate. It is happening due to the faulty capacitor yesterday. So if the capacitor is good one, then this capacitor providing what? The initial torque to rotate the ceiling fan. So capacitor need an electric fan, ceiling fan need a torque, an initial torque to rotate. It was provided by capacitor. So first capacitor stores some charges and it stores energy. That energy, because of that energy, what happened now? The ceiling fan get a torque from the capacitor. So it is due to the stored energy. So we are going to find a derivation, how we can calculate the energy stored in the capacitor. I believe that you all practiced the example 1.20 and the topic which I was taught yesterday, capacitance of a parallel plate capacitor. So today you can check the page number 56, energy stored in the capacitor. So energy stored in the energy stored in the capacitor. This is a derivation which is very important for your exam. So after watching this class, you have to practice by taking a book, you write and see. I always advise you to practice all the derivation. Don't just look and leave. Just practice it out. So first thing, it is very simple derivation. Yesterday I told the capacitor consisting of water, two plate, and capacitor not only store charge, it also store energy. You see, when the battery is connected to the capacitor, yesterday I told the same thing only. When the battery is connected to the capacitor, what will happen? The electrons transferred from one plate to another plate and minus Q plate. One plate becomes what? Minus Q, and another plate become plus Q. From this minus Q is transferring from one plate to another plate. So to transfer this charge, so like this, two plates, isn't it? Two plates capacitor. So suppose assume this is minus Q, this is plus Q. From here, transfer. So assume that when these electrons transferring from one plate to another plate, it needs some it does some work. So that is what a stored energy we are saying. Some work has to be done to transfer this charge from one place to another place. Isn't it? Without any work, how it will transfer? So, some work done by the battery to transfer this energy from one plate to another plate. So, that is what we are finding. But here, first we are finding how much work done by the battery to transfer an infinite cycle charge. Infinite cycle charge dq. For this, how much work done by the battery? This is what. For transferring an infinite cycle charge, I told you before last year and all, infinite cycle means what? Very, very small. For a unit area, for a small unit area, how much work done by the battery to transfer this charge from one place to another place? That is what we are finding. An infinite cycle charge. So, first you write the equation dW equal to V dQ. This will keep equation 1. dW equal to V dq. This is a what? Infinite cycle charge dq, and V means potential difference, isn't it? So battery did some work to transfer this charge, this infinite cycle charge from one place to another place. That work done first we are finding. So dW is equal to V dq. You know the basic equation, yesterday you have learned capacitance of a capacitor formula. What is the formula? C is equal to, okay, you can write that Q is equal to C into V. From this, C equal to what? Q by V. So Q is equal to C V. This is what our basic general formula. So C is equal to what? Q by V. This you keep equation 2. Now substitute from this what? From this we can find V. V is equal to what will come? Q by C. This you keep equation 2. So V is equal to Q by C. Substitute 2 in 1. Substitute equation 2 in 1. So what will you get now? dW equal to Q by C dQ. So this much this is the work done by the battery to transfer an infinite cycle charge. Now we have to find out the work done by the battery to transfer all the charges. This is only to transfer what? Infinite cycle charge. Now we are finding to transfer all the charges from one plate to another plate. How much work done by the battery? So what we will do? What you will do? You have to just integrate. So this you keep equation 3. Integrate this equation. So what will come? What is the integration of dW? Integration of dW. Then what? Integration symbol Q by C dQ. Q by C dQ. So Q dQ by C. Now what is the limit we will give to integrate now? Here 0, here Q. So from 0 to all the charges, all the total charge. That is what? Q. So integrate this equation. So W equal to 1 by C. C take it outside. Now Q dq. Here 0 Q. Now integration, you know. What is integration? What is this format? X dx. X dx means, you know, x square by 2. So integrate this. W equal to 1 by C Q square by 2 0 Q, upper limit, lower limit. Now W equal to 1 by C. Apply the upper limit. Q square by 2 minus 0. Now what will come? W equal to Q square by 2C. Okay. So now we know the formula for Q. What is the formula used to find Q? Q is equal to CV. Q is equal to what? Q is equal to CV. Substitute here. So what will come? W equal to C square V square by 2C. So substitute this CV in terms of Q. So what will come? C square V square by 2C. Cancel C and C. So what will come? W equal to 1 by 2 CV square. W equal to, already C cancelled. So 1 C is there, V square is there. So 1 by 2 CV square. So this is the equation number 4. You can keep. This is the work done by the battery. Now this much total work done by the battery to transfer all the charges from one plate to another plate. And you know, the work done is equal to the stored energy. So the work done is equal to what? Stored potential energy. So rewrite the equation. W equal to U equal to, U is what? Stored potential energy. You can use the symbol U equal to what? Stored potential energy. So 1 by 2 CV square. Now we got how much energy stored. Now we have to find where does this energy stored in the capacitor? Where does this energy stored in the capacitor? That is what we are going to find. For that, rewrite this equation or substitute C value and V value. Yesterday already we have studied two parallel plate capacitor having some area and cross-sectional area, and it is separated by a distance. So what? Yesterday we have found C is equal to epsilon 0 A by D. C is equal to epsilon 0 A by D, and V is equal to ED. There will be some electric field lines and distance. Then what are area of cross section there? So yesterday we have learned this formula, capacitance of a capacitor. C is equal to epsilon 0 A by D and V is equal to ED. Now this you keep equation 5. Substitute C and V in equation 5. Substitute the value of C and V in equation 5. So what we will get now? W equal to, now no need W because work done is equal to what? Stored energy. So stored energy U equal to 1 by 2. Instead of C what? Epsilon 0 A by D. Epsilon 0 A by D. Into, instead of V what? ED. E square D square. Here only cancel. So what is remaining? U equal to 1 by 2. Rearrange this formula and write now. Epsilon 0 A 1D is there, E square. This much energy stored. Where it is stored, that is what we are finding now. So you see, A is there, D is there. A means what? Area. A means area. D means distance. So AD means what? AD means volume of space. So AD equal to volume of space. Now there is a formula. UE is equal to U by volume. You see, some energy is stored somewhere in the capacitor, some volume of space. So, equation, this is what? Energy density. UE means what? Energy density. So, energy stored in the capacitor. Energy stored in the capacitor means what? Energy stored per unit volume. Energy stored per unit volume, we are saying energy density. So energy density means what? Energy density means what? Energy stored per unit volume. So you can rearrange this. What is U? 1 by 2 epsilon 0 A B E square divided by volume. What is volume? Area into length, area into distance. So AD. So AD cancel. AD cancel. So what is remaining? U E is equal to 1 by 2 epsilon 0 E square. This is the final equation. U is equal to 1 by 2 epsilon 0 E square. So this equation giving some inference, some evidence. Where energy is stored? Energy is stored. E means what? Between the plate electric field. So energy is stored in the existing electric field. This is the first inference. What is the first inference? This equation infer that energy is stored where? In the existing electric field. So energy is stored in the electric field. So when we discharge it, energy retrieved. So this is what this equation says. This is what this equation says. Energy is stored in the existing electric field between the plates when the capacitor is discharged. If you remove the battery voltage from the capacitor, the whole energy is what? Retrieved. And the second inference, what is second inference? It depends only upon the electric field. It does not depending upon the area. It does not depending upon the area or not the size. Not the size. It does not depending upon the size of the plate. It depends upon only on what? electric field. So the energy density, what is this? Energy density only depends upon the electric field. So again one more times, you can see the page number 56. Page number 56. All of you take page number 56. Now you see, go through this. First one paragraph is there. No, what? Just a story. You can write it. Capacitor not only store charge, then what? It also store energy. Then what you can write up? When the battery is connected, the electrons of total charge minus Q is transferring from one plate to another plate. So to transfer this charge, work done by the battery. So we are finding the work done. For that what? First, for infinitesimal charge. To transfer an infinitesimal charge dq, how much work done by the battery? That is what we are finding. dW is equal to V dq. So we know the formula, V is equal to Q by C. Substitute this Q in 1. So we will get Q by C dq. Now this is a work done to transfer infinitesimal charge. Now to transfer total charge, how much work done? W is equal to Q by C dq. Then what are? For that, integrator. Integration you all know. So Q dq means Q square by 2. Apply limit, upper limit, lower limit. Then Q means CV. So CC cancel, 1 by 2 CV square. Now work done is equal to what? Stored potential energy. Work done is equal to the stored potential energy. Now rewrite this equation by using C is equal to epsilon 0 A by D and V is equal to ED. Now substitute C and V in equation 5. So DD cancel. What you will get? 1 by 2 epsilon 0 A E square D. This one I rearrange and wrote that must only AD. AD means volume of space, area into distance. Now where it is stored? In somewhere it is stored. That is what we are finding. Energy density. What is this? UE means energy density. Energy density means energy per unit volume. Energy per unit volume. So what are U means the same. Volume. Volume means area into distance. So cancel AD. We will get this one. Then to inference. First inference is what? In this equation, UE 1 by 2 epsilon 0. Then only E is there. E, electric field. So charge stored where? Energy stored where? Between existing electric field. And it depends upon only on what? Electric field. Okay. So my dear students, this is one of the important derivations. You can check long answer question number 18. Long answer question number 18. Mark that and practice it. That will be helpful for you. It is easy for you. Thank you. Bye bye.